We have another example here of graphing a quadratic. Quadratic this time is in the form, or an example we're going to look at is negative x squared minus 2x plus 1. So we're going to go through it step by step to determine some of the key features of a quadratic. And the key features that we want to know are, does it open up or does it open down? Where is the vertex at? Where are its x-intercepts? And where is its y-intercept? If we can find those things, we can graph this quadratic fairly accurately. So let's start. What do you guys think? Does it open up or does it open down? Well, we remember that we look at the coefficient of the x squared term. In this case, the coefficient is a negative or a negative 1. And since it's negative, we know that the graph opens down. The second thing we want to look at is its vertex. And since this is not in that form where it has an h and a k, we're not able to identify the vertex by inspection. But we do remember that we did have that idea, where the vertex is at the point negative b over 2a, and then the function evaluated at negative b over 2a. So let's find out if we can understand what this is. So negative b over 2a, negative b is a negative 2. Since b is negative 2, 2 times a, and a is a negative 1. So what it looks like I have is a negative times a negative gives me a positive 2. Positive 2 divided by a negative 2 gives me a negative 1. So my x coordinate of my vertex is negative 1. And to find the y coordinate, we take that negative 1, put it back into the function, and see what happens. So I want to find out the function evaluated at negative 1. So I have a negative 1 squared. Because everywhere there's an x, I'm inputting that negative 1 minus 2 times the negative 1 plus a 1. Negative 1 squared is 1, negative 1. So negative 1 plus a 2 plus a 1. Looks like that gives me a 2. So my vertex is at the point negative 1, 2. So let's go backwards, negative 1, up 2. There's my vertex. I know that the graph bows downwards. So if it bows downwards, it's going to have to cross the x-axis. So I am expecting some x solutions. And that's the next part that we want to look at. What happens when my function equals 0? So let's take my function, negative x squared minus 2x plus a 1 equals a 0. Well, it looks like I have a quadratic. We can solve this by completing the square, or if we've already learned how to use that tool and built that tool ourselves, we can use a quadratic equation. So that's going to tell me that x equals negative b plus or minus b squared minus 4ac over 2a. X equals b, b is a negative 2, plus or minus negative 2 squared, minus 4 times a times c, all over 2, times the a value, which is a negative 1. And let's work that down. 2 plus or minus 4 plus 4. Is that right? Negative 2 squared is a 4. 4 minus a 4 times negative 1, that's a plus 4, so that makes an 8. All over a negative 2. And I can reduce that down some more. 2 plus or minus 2 root 2 all over negative 2. I can factor out a 2 everywhere. And I'm going to be left with a negative 1 plus or minus root 2. And there's my two solutions, negative 1 plus root 2 and negative 1 minus root 2. And that gives me solutions of approximately negative 2.4 and approximately, let's put that at 0.4. So those are my two solutions for x. And you can use your calculator, your black box, to go ahead and get that type of approximation. So I know that my graph is going to cross the x-axis at negative 2.4. So my vertex was over 1 up 2. So I have now my x's. So I got one x at negative 2.4, 1, 2, right there in the middle, positive 0.4. Kind of right about there. I'll put my vertex a little bit more accurately where the vertex is at. So I know the graph goes through those 3 points. One more point that I can determine, and that is, what is my y-intercept? Or what happens when I evaluate the function at 0? I like zeros because they make everything wash out. 0 minus 0 plus 1. So it looks like then that my y-intercept is at the point 0, 1. So there's 4 points that I know for sure are on this particular quadratic. And the quadratic goes down. So let's do everything I can to connect these points. My vertex goes down and then this way. So there is a very good graph or graphical representation of this particular function. I hope that helps you understand a little bit more of some of the dynamics, some of the things that we can find out on some of these problems.